All right, here again is the same chart from yesterday's video, and it's also in your textbook. Okay, it's all of our different antiderivatives that we will commonly see. So what we'll start looking at in this video is ways we can actually find what that C is that we're adding on the end. Now, in order to find what that C is, we need to know some piece of additional information so that we can actually determine a specific value for it. So in this example here, we have that our derivative, f prime of x, is equal to e to the x plus, I'm going to write this as 20 times 1 over 1 plus x squared. And the reason I'm doing that is because hopefully that then looks a little more familiar. We are going to take the antiderivative of this. E to the x's antiderivative is just itself. And then we have 20 as a constant. So remember, when you have a constant, you can ignore the constant to start, do the rest's antiderivative, and then multiply the constant back in. So we'll bring the 20 back in a second. 1 over 1 plus x squared, we just saw on the previous page, that is inverse tan's derivative, or antiderivative, sorry. So we'll have 20 times tan inverse. 1 over 1 plus x squared is the derivative of inverse tan. So the antiderivative of 1 over 1 plus x squared should be inverse tan. And don't forget to add that plus c on the end. Well, now we have this new piece of information, that f of 0 equals negative 2. Well, negative 2 is like a y value. We'll put that over here in for the f of x. And in place of all of our x's, we will put 0. So we'll then get negative 2 equals e to the 0 is 1. Our tan graph looks something like that. So therefore, at 0, tan is 0. Okay, this inverse tan of 0 is saying when tan is 0, what is the angle? Well, the angle happens to be 0, and 0 times 20 is just 0. So we'll just be left with plus c. And then to get c by itself, we'll subtract the 1 over. And we'll get negative 3 is equal to c. To finish this off, our actual equation of f of x is e to the x plus 20 times tan inverse x, now minus 3. So this is our specific function f of x whose derivative we had been given originally. It's no longer a family of functions with that plus c. It is one specific function. So let's try that idea again. They give us a second derivative this time, and we want to find the original. Well, first we'll find the first derivative. To find the first derivative from your second derivative, we've got to do the antiderivative. X squared will go up to x cubed. The 3 will then have to divide out front, so 12 divided by 3 will give us 4. X to the first will go up to x squared. The 2 will have to divide out front, so 6 divided by 2 will give us 3. And then a constant of negative 4 would go up to a linear, so we'll have minus 4x. And then we'll have plus c on the end. Sometimes the questions will give you values for f prime. We do not have that here, so we can't do any subbing in to find what c is. We're just going to have to keep it in the problem for now. So we'll go up another antiderivative now to f. So this will become x to the 4th now. The 4 will divide out front, and it'll just be 1. We'll have x cubed. That'll divide out front, and it'll just be 1. We'll have x squared. We'll divide out front, and we'll have negative 2. C is a constant. Will now become linear, so cx. And we've got to add another constant on the end now because we just took another antiderivative. Well, we don't want to use c again because that has certain meaning in our problem, so just pick some other letter. Let's say maybe d. Well, the issue is we have two constants to solve for now, both c and d. Luckily, they gave us 2 points. I would strongly suggest use the 0 to start out. We'll put in 4 for our y. We'll have 0 to the 4th plus 0 to the 3rd minus 2 times 0 squared plus c times 0 plus d. Well, that's going to give us just 4 equals d because all of it will wipe out. Now keep in mind, when you put 0 in, we don't necessarily always get stuff to wipe out. What if you had a cos in there? Cos of 0 is 1. What if you had an e to the x in there? E to the 0 is 1. So don't just assume that when you sub 0 in, it wipes everything out. You've got to actually think about it. So let's rewrite what we now know. We now know f of x is x to the 4th plus x cubed minus 2x squared plus cx. But we now know what d is. We know d is 4. So we'll add 4 on the end. And now we'll use our other point. F of 1 is 1, so we'll put in 1 for y and also 1 for x. And we'll just solve for c. So this is going to give us 1 equals 1 plus 1 minus 2 plus c plus 4. That part adds to 0, so we'll have 1 equals c plus 4. And when we subtract our 4 over, we will get negative 3 is equal to c. So to finish out our problem, our actual function for f of x is x to the 4th plus x cubed minus 2x squared minus 3x plus 4. So essentially, however many antiderivatives you are going to take, to find the actual function, you need that many points to work with. We took 2 antiderivatives, so we needed 2 points. Now, sometimes they'll give you one of those points in a first derivative and one in the original function. In this case, they gave us both in the original function. If they had given us one in the first derivative, we could have subbed in there to find that first constant right away. All right, we now have a particle is moving in a straight line. It has acceleration given by a of t equals 6t plus 4. Remember, acceleration is the same as thinking your second derivative. We're given an initial velocity, v0, of negative 6 centimeters per second. Remember, that's like a point in our first derivative. And an initial displacement or initial position of s0 equals 9. That's like a point in our original function. And we want to find our position function. So let's start out, let's find v of t. V of t will be the antiderivative of our acceleration function. Well, 6t, t will become squared. The 2 will divide the 6 out front, which is 3. 4 was a constant, so it becomes linear. We'll have 4t. And then we need some constant on the end. Well, they told us our initial velocity at time 0 was negative 6. So let's sub in negative 6 for our velocity. We'll have 3 times 0 squared plus 4 times 0 plus. We will then get negative 6 equals c. So our actual velocity function is 3t squared plus 4t minus 6. From that, we can now find our position function, which is the velocity's antiderivative. T will go up to 3. We'll divide the 3 out front, and we just get 1. This will go up to squared. We'll divide the 2 out front, and we'll get 2. Negative 6 now becomes linear, and we've got another constant on the end. Let's say plus d, just not to, so we don't confuse it with the c from before. They gave us an initial position of s0 equals 9. Sub in 9 for our position. We'll sub in 0 for all of our times. This will give us 9 is equal to d. And therefore, our final position function, we have t cubed plus 2t squared minus 6t plus 9. And that is the function that will give us the acceleration that we wanted and also have each of those initial values for position and velocity. So many of you have seen things like this in physics, but if you have an object that's near the surface of the Earth, it is affected by gravity. The force of gravity is either 9.8 meters per second squared if you're working with metric, or if you're working with the English system, 32 feet per second squared. Now, we choose the positive direction to be going up. So therefore, gravity's force is coming down, so we represent that as a negative. So you've probably seen in physics, you usually work with meters. So you've probably seen negative 9.8 meters per second squared to represent your gravity constant in physics. The problem we're going to look at right now, though, is going to deal with feet per second. So we'll have to use that negative 32 for our acceleration constant for gravity. We're going to do two things, or three things. We're going to find our position function. We're going to use that to find the maximum height, and then we'll also find when it hits the ground. Notice we don't have any equation to start with. Well, we can start with the acceleration constant of gravity because our object's being thrown in the air, which, because we're with feet, it'll be negative 32. We can then take the antiderivative to find our velocity. Antiderivative of a constant is linear, and then we'll add our constant on the end. Well, they told us in the problem that the ball was thrown at 48 feet per second. That is your initial velocity. So therefore, it's like we have v0 equals 48. And while we're at it, that 432 is your initial position. So it's like we have s0 equals 432. So we'll use our v0 equals 48 to find our constant. This will just give us that c is 48. So our actual velocity function is just negative 32t plus 48. Well, the first thing we wanted was the position function. So we therefore need to take another antiderivative. So t will become t squared. We'll have to divide a 2 out front, so we'll get negative 16. 48 was a constant. It'll become linear, so 48t. And we have to add some new constant on the end. We will now use that initial position of s0 equals 432. So we'll have 432 equals negative 16 times 0 squared plus 48 times 0 plus d. And this will give us 432 equals d. Therefore, we can determine our actual position function of the object to be negative 16t squared plus 48t plus 432. And that accomplishes the first thing we wanted to do in this problem. We wanted to find our position in terms of our time t. The next thing we wanted to do is we wanted to know when does it reach the maximum height. Well, this is a quadratic with a negative a value, so it should be a parabola opening down like that. Our maximum height will occur here. When our maximum height occurs, our tangent line will have a slope of 0. Your tangent line will have a slope of 0 when your derivative is equal to 0. So we can take our velocity function, And we can set that equal to 0. And again, we're doing that because at the maximum height, we should have a tangent line slope of 0, meaning that velocity should equal 0 at that point. If we divide the negative 32 over, we can take a 16 out of each of them. So therefore, we will have 3/2 seconds. Again, we're just dividing the negative 32 over, negative 48 over negative 32, reduces to 3/2 seconds. The third part we wanted is we want to know when it hit the ground. Well, it will hit the ground when the height is 0. That's our position is 0. So we'll then do 0 equals negative 16 t squared plus 48t plus 432. All of these are divisible by 16. So we're actually going to divide everything by negative 16. So that'll be 0 equals t squared minus 3t minus 27. And now this is something that's a bit more manageable. There is nothing that will multiply to negative 27 and add to negative 3. So we're going to have to use quadratic formula. Under our radical, we will end up with 9 plus 108, which is 117, all over 2. So we got 3 plus or minus the radical 117 all over 2. So again, the 117 came from doing 9 plus 108. 117 can be broken down. Nine and 13. So we really have that t is 3 plus or minus 3 square root of 13 over 2. Well, your negative 1 will give you a negative time. We can't have a negative time, so therefore our only answer where we're going to hit the ground is 3 plus 3 square root of 13 all over 2. And that's a time, so we have seconds. So the three things we found in reverse order, we just found the time that the object will hit the ground. We found in the green there when it will reach its maximum height. And then in the red, we found our position function by taking our antiderivative from a constant acceleration. That's it for this video. We'll see you next class period.